this video we're going to go through adding polynomials, and the main thing to remember when you add polynomials, basically it comes down to you want to combine like terms. And a like term is going to be a term that has the exact same variable and the exact same exponent. So when it's addition, we can see we have addition in between these two polynomials. What we're going to do is we're going to find the like terms. So we can see we have a 9a squared because the variable is a and it's being squared. I can only combine that with another a squared. So I go to my second polynomial and say, oh, here's another a squared. So when I put those together, I have a 9a squared plus another a squared. That's going to give me a 10a squared. We do want to keep in mind that we want our answers in standard form when we do this. Standard form means you start with your highest exponent of your variable, so we have a squared. The next term in my answer should be an a to the first power if there is one. So as I look at the problem, we see that there's a plus 3, but then there's this minus 4a. Well, that 4a doesn't have, or that minus 4a, we're going to treat that like a negative 4a. That does not have a like term to combine with, so in our answer, it's just going to stay negative, a negative 4a, and not combined with anything else. And the last thing we're going to look for is, well, I guess anything else, but any constant terms. This plus 3 right here, that's a constant term. You look for any other constant terms to combine it with, and because there are none, we'll just say plus 3 off on the end. And then every single like term got combined, and that will be our final answer for that example. Alright, the second example, we have a polynomial plus a polynomial. To get our answer in standard form, we do want to look for the highest exponent. I see there's an x to the fourth. If there's an x to any other higher power, I would start there, but because that's the first one, we will go ahead and start with the x to the fourth. So I have a 2x to the fourth. We're going to add any other x to the fourth to it. So I look at my next polynomial, I'm going to see there's an x to the fourth. So 2x to the fourth plus x to the fourth gives us 3x to the fourth. After the x to the fourth, I do want to look for any x cubes because I'm going in descending order of my exponents. Here's an x squared, so I don't want that one, but over here I can see that there is an x to the third power. And because of that subtraction, that minus in front of it, we will see this as a negative 2x cubed. So that will just go right in our answer, negative 2x cubed, nothing's combining with it. Alright, now we need an x squared. Here we have I'm trying to make all these symbols a little different. There's a negative 3x squared, and I see we have a negative 4x squared. So when we put those together, a negative 3x squared and a negative 4x squared, we're just adding the coefficients out front, we get a negative 7x squared. And then last, any constant terms, we have a plus 3 and we have a plus 4. So 3 plus 4 will give us 7, so plus 7. And we've combined all our like terms, our answers in standard form, highest exponent starting us off, and then descending order of your exponents, so this one is done. So again, when you're adding polynomials, just remember you are combining like terms.